So you joined in on our webinar series, and this one's called Using SOLIDWORKS MBD to Drive the Inspection Process. I'll be talking quite a bit about model-based definition, but really in the context of how do we use this in other parts of the organization, specifically with quality and inspection. And if you guys have attended one of my webinars before, I've covered some of the details of MBD, and we'll be doing that in future ones as well. But we're going to kind of focus on not just SOLIDWORKS MBD and what that does, but also how that plays with SOLIDWORKS Inspection. And then I'll also spend some time over in Geomagic Control X, and the two of the tools that we have within the GoEnginneer arsenal for inspection and quality. And so that's the main focus of today's webinar is how do those things play with one another, and how does MBD start or drive that process. So model-based definition, this whole area is fraught with three-letter acronyms or abbreviations. And so let's talk a little bit about PMI, Product and Manufacturing Information. As you can see from the graphics over there on the right-hand side, this is a lot of times what we use in dimensions, in geometric tolerancing frames, datums. It's how we're giving information about the geometry and or the processes we want to create that geometry. So we see that very traditionally today in our 2D drawings. And so that's one of those areas where that shows up. But it's also things like that we don't see on the screen there: surface finish symbols, bill of materials, notes. Those are also part of what we would consider PMI, Product Manufacturing Information. Another acronym that we use here is TDP, Technical Data Package, and especially if you are a vendor or somebody that's working with military, aerospace, and even automotive, TDP is a pretty common term there. And it just is not only what we produce with the PMI, but it's also grabbing things like quality inspection manuals and maybe end of life documentation. And then the other one that we want to cover here is MBE. MBD and MBE are being used kind of interchangeably, but it's just where the entire organization has adopted a model-based philosophy and are implementing that in multiple areas, not just in engineering and manufacturing. And so those are ones that we see. I also hear art to part, which 20 years ago, whenever I started chasing MBD, that was actually the term that we placed on that. And I think aerospace folks like Boeing are still using the term art to part. And so we're all talking about the same thing, and that's part of why we share this type of information up front. But for the clarification and to help us understand in the context of this conversation, as well as any other you'll have with GoEnginneer, this is GoEnginneer's definition of what model-based is. And that is that we're going to annotate our critical manufacturing data directly into our 3D model rather than putting that on a 2D drawing. And so, also to kind of, go a little further there, that doesn't mean that we're going to put every view, every annotation, every dimension that we've done traditionally on a 2D drawing and just transfer that over into a 3D environment, because we feel like that would be at best a wash, maybe even a little bit cumbersome to do so. And so what the philosophy of model-based definition is we're trying to gain an efficiency by reducing the amount of information that we have to convey via these vehicles like a 2D drawing or even a PDF of a 2D drawing. And so what we're trying to get to is conveying our design intent, our PMI, directly with the model. And there's different classifications and levels. Most of our customers are in what they call classification 2, whereas the drawing may still be the driving document, but the model is supplementary and complementary. And then what we'd like to do is move to a class 5, wherein all of the information is conveyed via the model, and we don't even need a 2D drawing anymore. And that's really been my goal for 20 years, as well as our renewed goal when we're talking about model-based definition. I want to look at this graphic again. If you've attended one of our webinars before, we've shown this in relation to MBD. And this is how and where in your organization PMI is typically consumed. And so this may help you frame, maybe use all these areas or only part of these areas today. But we feel like the combination of the 2D drawing and the 3D design drive in different areas. We're using things like photorealistic rendering in our visualized product for marketing. We get into design for manufacturing and using things like Composer for work instructions. We get in there at the assembly level using those models. But a lot of times today, we still see 2D drawings driving the manufacturing and or the sourcing or the purchasing area of this. And so we want to use models not only just in CAM and mold design and sourcing, which is pretty common to what we see today. We actually want to cut out the 2D drawing and move those to where we're getting the 3D design. We all know as SOLIDWORKS users, we're able to pull the bill of material directly from the model. That's where the drawing actually gets the bill of material, is from the model. And we'd also like to drive more the manufacturing process with that as well. And if you saw highlighted there, inspection, that's the area we're really digging into today. And so I want to now turn over and start focusing on that specific area. So again, we're going to look at SOLIDWORKS Inspection first, and then we're going to move over into Geomagic Control X to do a little bit of real world stuff as well. All right, so let's flip over here into SOLIDWORKS. I've got a couple of different examples and scenarios that I want to look at. MBD is an add-in to SOLIDWORKS CAD, and so what we get with that add-in is we get a toolbar up here at the top. It's in my ribbon toolbar, and it's got a set of tools that we use. Now, a lot of the tools that we start capturing our PMI with is a suite of tools we've had for many years called DIM Expert. And that's where I want to start off with this particular model today. I want to come over to my DIM Expert tab, and I'm going to capture some PMI on this model. And one of the beauties of using DIM Expert is I'm not reliant on the features that were used to create this model. You know, maybe I got this from a vendor, or maybe I've got a junior level designer that's just getting started on their career, and they may not model the way that we manufacture. And or maybe you have multiple manufacturing methods that you need to be able to account for. So what this DIM Expert auto dimension scheme is going to allow me to do is to select 3 datums that are important to me. And kind of a tips and tricks for you here, I'm right-clicking in between each of those selections, and it keeps me from having to move my mouse very far by selecting those 3 datums that I want to work from. So left-click to select the face, right-click to accept it, and it moves the selection box down over here on the left-hand side. So that's a first takeaway for you today, is you can right-click in between selection to keep from having to move the mouse too far. This is a prismatic part. And I'm going to use the geometric tolerancing scheme on this. Any patterns, which I really don't have on this one, would use a linear method. And then you can see down here the filter is down at the bottom where I could possibly deselect certain type of features that I do not want to be included in this process. But a nice green check mark there is going to analyze my model, and it places datums on each of the 3 faces that I chose. And it brings us back with a DIM Expert scheme. And I can see from the color verification that all faces are green. That lets me know that all of the definition has been made in order to completely create my PMI for this geometry. And I may have other process notes and things that I need to add, but at least for my geometry, everything's covered. There's a show status, tolerance status, and I can select or deselect that in order to color code any of my faces. This is a pretty simple part. It has all the definition that it needs using the auto dimensioning scheme. Something else we can do over here in the feature tree is a right mouse button on that top level, tree display, and I can choose to show this as a flat tree. And what that'll do is not only give me the features that were created, but it also shows me things like the datum annotations, flatness, perpendicularities, and other tolerance frames that may be applied over here. That's a personal preference that I have to see that in a flat tree view. And that was a right mouse button, tree display, flat tree view. All right, so I've got some PMI captured in here. And a lot of times whenever I do this, people are like, oh, wow, that's demo magic, because you got all these tolerances that popped up, and how in the world were those defined? And so you may or may not know, but in your templates that you use every day in SOLIDWORKS, under Document Properties, in DIM Expert, this is where all those tolerances are set, and they're set per template. So that way you can come in here in your template and you can determine you've got diameters bilateral at a 1/4 millimeter, lengths, depths, counterbores, countersinks, and so on, locating dimensions, chain, geometric tolerance, and so on. So it's not really demo magic. It is just a matter of my template being set up, and it's extracting those template tolerances whenever it's using the automatic dimensioning scheme. So that's pretty nice. So one of the aspects that we really like about MBD is being able to capture and still convey our design intent and help others walk along in the process. And so whenever you have MBD, down at the very bottom, there's a 3D Views tab, and we're able to capture 3D views in order to show on here. And so I've got a few of these already captured, but I'm going to capture one from scratch here to show you what that might look like. And so I can use the Capture 3D button, and I can give it a name. So let's just call this Webinar ISO. All right. I'm going to use the default configuration. I could choose multiple configs of the model if I had those. I also can choose one of the display states that are available. I choose what annotation planes are being used, and I'm going to go ahead and grab all those at the moment. Green check mark, and it's going to capture that view for me. I can cycle through any of those captured views in order to be able to help convey, very similarly that we do in a 2D drawing, what annotations I want a user to see at any point in time. It not only is capturing the camera angle, the display state, and the configuration, but it's also grabbing the annotation state. What annotations do I have shown? And so we can see over here in our feature tree, we also have the annotations and annotation planes available. I want to activate my notes area. This is a flat to the screen area that SOLIDWORKS has given us, and we can do things like, let me move this guy down. We can do things like grab a hold of a note. I know this one is a millimeter, so I've got a millimeters note, and so I can grab a hold of that, drag it out of my library, and add a note to this notes area. And if we zoom up in there, you can see some of the critical dialogue that we use in MBD. Things like interpret drawing in accordance with ASME Y14.5-2009, as well as the Y14.100-2013. Those are two standards that we use with MBD to help us define how these models are to be interpreted. You also can do things like having them understand that everything's a basic dimension, or that surface tolerances are, say, 1/4 millimeter for anything that's not toleranced. These little details like this are how we reduce the amount of information that needs to be shared when we're doing model-based definition. So this would be the traditional sense. I'm defining a machined part using a lot of geometric tolerances. But what I also want to show you is another example today. And so this would be, say, a plastic injection molding part. And we may or may not have the same type of tolerances associated with those. And so we found in conversations that some people are like, well, we don't have a need for MBD. We just do plastic parts. Well, I would say, no, you absolutely need MBD, model-based definition, because that is, we sync more molds using models than we do traditional 2D prints anymore. It's just an efficiency that we do. And so rather than going through and using a dim expert scheme and defining a lot of datums for a part that may or may not need it, what I need to do is I just want to use some of my feature dimensions. And so I'll right click on annotations and choose show feature dimensions. And then when I want to create a new annotation view. This is just going to help me declutter some of the information on the screen. So another right mouse button on that annotations feature, and choose insert new annotation view. So in here I've got a general orientation that I want to use, and I'm going to use our front orientation, and I'm going to hit the next button in order to choose which annotations I want to move over into this new annotation view. I'm going to grab a couple of locating and size dimensions. I'll grab my overall corners. There's another locating, a couple more locating dimensions, and maybe another size and location dimension. Maybe those are the ones that I want to be conveyed and shown. And so a green check mark there, can highlight that, and I can choose to either hide or turn off, deactivate any of the other planes and annotation views in order to declutter what I may or may not want to show on an MBD print. Same way over here, I could capture a 3D view and be able to cycle to that. At this point in time, I could publish these 3D views using 3D PDF, e-drawings, or keep those natively in the SOLIDWORKS model. And that's what I'd like to do, is I just want to keep these in the SOLIDWORKS model. Moving to inspection, I need to be able to show somebody on the floor which of these dimensions are important to me and which ones I need to be checked. For a lot of shops, they're either doing 100% just because they don't have the documentation to clarify, or they don't really know what they need inspected. SOLIDWORKS Inspection is an add-in that works both on models as well as drawings. And so in the vein of MBD today, we're going to do this directly on our model. So I'm going to start off by creating a new inspection project, and we've got a lot of front-end templates, just like we do have part and assembly and drawing templates on the front end of SOLIDWORKS activities. We want the same thing here. These are going to define things like our title block tolerances, what balloons, sizes, and shapes that we want to work with. And so I'm going to use the default out of the box. And I want to, for today's purposes, I'm going to use a manual extraction method, because I want to select the particular dimensions that I want to use on this part. I'll pop back over and show you the little gray part using an automatic method in just a minute. So green check mark on that, and now I want to add characteristics. And I can come in and start selecting the individual dimensions that I want to add as characteristics. And I could do a drag box around those, but I want to kind of put them in a certain order. And so I'm selecting them each individually, one at a time, and you can see that the system is ballooning and extracting the characteristics information from each of those dimensions as I select on those. So very, very cool process in order to be able to capture a characteristics list over here on the left-hand side of the screen. Most of the time, the reason why we want to do this is we want to turn around and create, say, an AS9102, which may be a first article inspection report. And you can see SOLIDWORKS Inspection has a few different templates out of the box that we're working with. I'll just use that AS9102, and it will quickly gather up those characteristics and fill out my form of where I want that to be. I'm going to save this into my PDM vault today underneath my quality assurance and inspection area. And we'll just call this WebMar 13. Now, I would probably use PDM to have a serialized quality number on this if I were out in industry, but here in the safety of the VAR community, I can get away with giving it a verbose name like that. It produced that report for me over here in Excel. There we go. And you can see that it makes a very nice, clean report that we're able to capture and to put into our PDM vault and start the process of our inspection. So we have a balloon characteristic number that goes along with our particular characteristics and the information related to each of those. And that's something as simple as just a few overall locating or size dimensions for our part, and helps document that process. I mentioned to you that I would show you the automatic method. Let's do that over here on our more prismatic part. Same thing, new inspection project. And one of the things I didn't show you on the other part is you have the ability to link to project information, so we can have that carried over into our forms as well. And I'm just double clicking on those buttons in order to gather the custom properties from the model and bring those over into our inspection project. And this time I'm going to use the automatic method, create an auto balloon. And one of the things I did not show you a while ago is the types of entities that we can extract. Things like dimensions, getting chamfers and splitting those up into an angle and a distance. Taking our notes, exploding those out. Geometric tolerancing frames, whole callouts, and so on. And then the last tab over here is our title block, or our SOP tolerances. Standard operating procedure. And so whenever I clicked on the green check mark there, it's extracting all of the critical information, building that characteristics list programmatically for me. So if I've got a few more characteristics than I did on my simple plastic injection molded part, I can do that, and it brings back that characteristics information for me. And you can see it does things like it reads in the value, it knows it's a length dimension, it does the upper and lower computed limits based on our tolerancing. We can set AQL based off of these values. Anything that we need specific to our inspection process, at any point in time we can kick out that AS9102 Give that just a second to gather that information. I'll just save this one over as Dim Expert. We got quite a few characteristics in this one, and so here we go. All of our notes, geometric tolerancing frames, and so on are all built out in our characteristics report. So we started the process with MBD, captured the PMI, and then we're documenting this using SOLIDWORKS Inspection in order to drive our inspection process and our gathering of our measurements and our results. So that's kind of the second step on our tour. I'm going to switch over now and use one of our other partner products called Control X. This is from 3D Systems Geomagic, and in here it gives us the ability to pull in scan data. We use the Creaform structured light and laser scanners here at GoEngineer, and it's an inspection method that allows us to be able to work with both of those systems. So in the vein of MBD, what does MBD and inspection have to do with one another? Well, these systems have gotten a lot more sophisticated, and what we can do now is I can read in the PMI information directly from CATIA, NX, Creo, or SOLIDWORKS using the Geomagic tool. So Control X allows me to be able to read in my PMI information, say on that Dim Expert part that I created a while ago, and I didn't have to do anything else to the process. It comes in and it starts building up the setup data based off of my MBD PMI. You got your fill of alphabet soup yet? We'll talk about that here in a minute when I turn on the mic and ask you guys questions. But you can see here that it's able to read in all of that information and understand the setup of where the datums are and what our tolerances are based off of that. So now once I've got my PMI information in, I can now go import in my measured data. And so for here, I've got an STL file that's representatory of my scan. Oop. Let me kill that one real quick. I know that this part was measured in inches, and I did not choose that. Here we go. Awesome. There we go. Now we can see our scan data is in green and our model data is in gray there. And what I need to do is I need to align those. And so I'm going to do an initial alignment. Control X is going to take that scan data and it's going to say, hey, we've got some stuff to move over. Do you want us to move that? Yes, please move it with it. And then I'm just going to do a best fit alignment here just to verify and make sure that everything is exactly aligned the way I want it to. So a few clicks here. And if you guys are Control X users, I know we've got at least one in the audience today. One of the neat things is I can save the alignment data in this with the CAD data, not the measure data, and I can reuse this template over and over and over again each day. If I've got to measure 20 parts, I would have my 20 measured data and I wouldn't have to do the alignment each time. It remembers that from the initial setup. Makes it very, very cool. I'm going to hide my CAD data for a minute, and you can see we start getting some visual reporting. See all the little green tags out here? That's letting me know that those particular dimensions have been satisfied, and they're showing up in green. That's pretty cool. Another thing that we like to do here is say a 3D comparison, wherein I can get a little bit of a heat map of what's working and what's not. And so very, very cool that we can start to get the histograms and heat maps based off of comparing CAD data to the scan data. All of this MBD. You guys saw me do this in 25 minutes on being able to work through these parts from scratch. I do want to show you a 2D compare on this as well because there's something kind of interesting in here. Let's drag this guy up there. Say OK, and I'm going to hide the 3D compare. So from here we can see that this hole has a misalignment, and I can start seeing how much misalignment it has based off of those datas, and knowing bonus tolerancing, what I've got going on with the holes. Does it meet criteria, not meet criteria? And so MBD's able to help drive that process and let us see those things. And then if you guys aren't familiar with Control X, we can do things like generate reports very quickly, which I don't have the this is the generic report. I'll have the details. But we get the CAD data, we get the scan data, get a little bit of the statistics, alignment information, start getting our heat map related to tolerancing, our 2D compare, and then here towards the end we start getting into individual characteristics. I know I'm scrolling kind of fast there, and so it may be choppy coming across on the go-to. I apologize for that. But you can see we make pretty quick work out of the process of going from MBD through inspection on over into an actual inspection method. I'm using our Geomagic Control X and our Creaform scans in order to be able to do that. But you could use traditional CMM, CT, or visual is becoming more and more popular. And so with that, I'm kind of seeing my time is pushing a little bit. So let me flip back over here. Clarify a little bit. SOLIDWORKS MBD is what I started off with. It's an add-in into SOLIDWORKS CAD. Lets me organize and grab my PMI information, and then I can use templates in order to drive out whether it be a Step 242 file that I can use on CAM or Inspection or a little bit of anywhere. And I also can create those 3D PDFs that are template driven. So I get to control what the user sees. I use SOLIDWORKS Inspection in the middle to quickly gather characteristics and produce those into whether they be a first article inspection form or an in-process form, any kind of form where you want to show and capture what characteristics are needed. And then lastly, I finished up there with Geomagic Control X, wherein I'm reading in that information, extracting and gaining efficiencies by having MBD data in those files, overlaying my scan data, and then doing comparisons and reports out of that process. My name is Tandy Banks. I want to thank you for joining GoEngineer's webinar today on how MBD can drive the inspection process.